Welcome everybody. Thanks for coming. I'm just presenting this talk about functional programming. So let's do first things first. My name is Mario García. I'm a software engineer at Kaleidos here in Madrid. I'm a Groovy enthusiast. I'm a member of some, well, just two, Groovy User Group, one in Dublin and one here in Madrid. Those are my social addresses in case you're interested. Let's go. Okay, so what's functional programming? Well, first time I thought about this talk, I planned to be a little bit academic, but then I thought people might get bored because of some description taken from the Wikipedia. And I don't want people to get bored. I don't want people to walk away from my talk. So then I changed my mind, and then I thought, well, you know what? Wouldn't it be great just to show how functional Groovy may be? Do something extreme, you know? But after many hours, I got to this, okay? And two ideas came to my mind. The first idea was, Groovy is amazing. You can do crazy things with Groovy. You can do something like Clojure, because if you didn't notice, this is not Clojure, this is Groovy, okay? It's a DSL that looks like Clojure, but it is not. And the other idea was, well, maybe you have spent too many hours in front of your laptop, you know? So, no, neither the two approaches really like me, because I wanted to show you why functional programming matters. What is important to us as Ruby developers to use functional programming, and what patterns require TMC. Anybody? Too many classes. Okay, so it's again you go to square one and start doing copy paste again. Okay, and there are many other things that we are really tired of doing, such have to know how to open and close a file. Things that we are going to see later on. Groovy just provide us. So, I just want to focus not on every single concept in functional programming, just two of them, just today, because we have limited time, just to focus on two ideas, tackling accidental complexity and modularity. Okay, what is accidental complexity? Well, I think it's those things that don't let you do what is important to do in your code. So, when you are just focusing on just getting a single value, why just bothering on knowing how to open a file just to look through the file and many other things that are not important to the problem? Well, we'll see how to deal with that. And modularity, well, modularity is a very similar concept. We have been studying for so long, even in object-oriented design. So it's just a matter of building small pieces in order to build bigger pieces on top of them, okay? So instead of using patterns as we used to do, we'll see with higher order function our clusters, just to speak. Let's evaluation really help us to improve our code, to reduce it and reduce the complexity, okay? So there are many other concepts, of course, in functional programming which are important. Such as immutability, okay? Especially when you're dealing with multi-threaded environments or programming concurrently or doing some parallel collection, immutability is an important concept, okay? And of course, the M word, okay? Well, monads, I would say, require not only a talk, but the course. But I didn't want to enter that, so I'm only going to tell you that sooner or later, you will face them. So just be prepared, okay? But okay, so it's not about the language. What I wanted to mean by that is that as long as your language provides you with the tools and the features that enables you to do functional programming, well, you can do functional programming. It's not a matter that because you are using Groovy, you are not able to do functional programming. Not at all. Because Groovy helps us a lot and has many special and wonderful features. So it's about the way you use your language, okay? just a moment just to see the big picture about the JVM and how Groovy is functional in some way. Well, we have, you can see there, JDK8, Ruby, Clojure, and Scala, okay? And I think Groovy, I have showed you some slides before, it could be very functional and can go very functional, okay? Then there is Java 8. Well, they have been catching up a lot. They have improved a lot, okay? So I guess they deserve a little bit of recognition because they have improved a lot and they can be very functional nowadays with JDK 8, okay? Then there is Clojure, of course, that is like looping through pure functional, and they are very functional. There's still some corners because of, I guess, because of compatibility with interoperability with Java, and they have their corner cases. And of course, there is a Scala, which I guess because they have chosen to be half object-oriented and half functional. Well, in this slide, they don't move at all, okay? So, is Groovy a functional language? Well, it's not a pure functional language, but good news, you can do functional programming with Groovy. And who wants to be pure anyway, okay? So, yeah, I'm going to show you some code just to discuss a little bit the two topics I just put in the slide, okay? So I'm just going to take a seat and see some code. Some disclaimer is live coding, so something can go wrong, okay? Let's see. The first topic is accidental complexity. So here I have like a CSV file with all NBA games from 1949, and some client has just asked me just to get some information from that file. So the first requirement is to get the maximum visitor score of an NBA game. So because I'm right now an imperative programmer, I just code imperative mess. So let's see how it looks. So because I need like a counter, I just create this counter, and then of course I have to take care of how to open a file. I have to take care of how to load the file. Then I have to do some strange things here in some assignations. Any of those lines could be my last line. Okay. Then I have to, of course, update that counter that was something on top. Whoa, it's still high. Okay, so, and then of course this try catch block in case something went wrong. And of course, eventually I have to remember to close the file. So I guess too many lines of code for doing such a little. Okay, so let's see how it could look like in imperative Ruby. So we still have this this variable outside the loop, but in the other side we have Ruby just providing us a way of nicely loop through a file. Not only that, but you can tell Ruby just to split every line of the file by a given token, in this particular case, a comma. So at least there are many lines of code saved here, okay? By the way, you can just ask anytime you want, okay? So here we still have this assignation, but we don't have to split anymore here. And then we still have this, this comparison. We still have this try catch that we'll see later on that maybe is not necessary. It's just the way we are designing the code. Okay, so there is an important change here. We are not taking care of each line. We are saying to somebody, in this case Ruby is like saying, instead of me taking care of for each line, just split the line and then take the tokens, I'm just saying, look the file and give me the tokens just to be focused only on the important thing, that is taking just the value number 2 of all the tokens of every line, okay? So let's move and see a little approach here. Here, again, we are not worried about opening a file and be worried about closing it. Ruby just provides us, and we have get rid of all that complexity so far, okay? here we have reduced as well the comparison, just saying, okay, I just want the maximum value between the maximum score so far or the value that I'm interested in. Still, I have this try-catch block that is getting me mad because I have the feeling that it's not necessary, but still, I don't know how to get rid of it, okay? So let's do one step further, and here I can see more descriptive, saying, okay, so I'm just looping a file. Well, let me put this in several because otherwise we are not going to see it. So we are looping a file and then getting all the values for a given field, and then we are getting the maximum value of all of them. It's clear, it's just 4 lines, but nobody's going to say anything. I mean, it's not a matter of just obfuscating the code, no? Just this try is a little bit weird. Maybe I can just say, I don't know, but we'll see later on, because I want to refactor that in a way that I want to be more descriptive. Well, maybe we can just do a lucky guess. Here I can say, I want just the maximum visitor score, and because this is just a Clojure visitor score, I can just do this, okay? So this line is very descriptive, okay? We are looking through a file just to collect the maximum visitor score and then getting the maximum value. So here we'll see how to refactor this line that I don't particularly like it because this try catch is a little bit weird. It looks like a confiscated code. But this line is pretty clear what it does. We are collecting the visitor score and then the maximum value, just in a few lines, okay? So if we have to refactor that, it would be easier for us. Okay, so let's move on and see how modularity can be accomplished. Let me just recite this, some more code. So we had this client that was asking us just for get some values. We had this mess of code, but we were all happy. My boss was happy, my client was happy, and I was happy because it did the work. So the code was doing the work. Nobody was caring on how bad the code was. But you know what? Normally, the client is going to call you again, and then it's going to ask you for more. Okay? So because you just coded a mess, you just ask for a little patience because you know maybe I have to refactor it. It should take a while. You can just come up with a lot of excuses. But in the end, you have to face it and say, oh, how I'm going to do it, how I'm going to refactor the code. Maybe I can just be elegant and use some pattern that I'm aware of. But because it's late and I have to go home, in the end, you just end with this horrible refactor. Okay? Because you know what, it's just a matter of having a flag there and just changing one line. And maybe you just even don't change the name of the variables. Because, but again, you are happy, your boss is happy, and the work is done. Okay? But reality is far much worse. Okay? Oh. So your client eventually calls you again, not only with one, but many other requirements. Okay? And of course, it always has to be done in 2 hours or somebody is going to get fired. So you end up with a face like this. So we cannot go on the same way we used to. Somebody has to change. So we cannot do the horrible refactoring forever. So we have to change the way we are coding. So taking again this example I showed you before in a more functional way, we are going to start from that. So instead of creating like a template pattern, like doing an abstract class, and then we are reusing it in order to accomplish more objectives or more goals, we can do that just with a method and using Clojure. So here we were just collecting the maximum visitor score, but I have just done a generalization of the code, and I have just find out that I can just pass a Clojure as a criteria. Well, it's more like a collector, right? It takes care of how the data is collected through the lines. So I'm just using the template pattern here. I'm just looping a file, then I'm collecting some value from each line of code, and then get the maximum value. I didn't have to create more classes, okay? So I can just extract the maximum difference as well, and many other things that come across, okay? So far at least we are reducing the code, and we are doing things in a way that is easier for us to refactor it and to extend it. So let's move a little bit forward, but before just moving into another example, I want to show you something. So I think most of us are aware that the power of the closures in Groovy, but when talking about functional programming, there's something that I'm really excited about it, which is closure composition. So let's say we have like a bunch of numbers, and let's say we have to do something with them. So let's say we have to collect just double of each number, and then maybe we need to, well, we have several business rules. So the first one is just to double the number. The next one, sorry, I will say it this way. It will be more graphical. Let's say we need to double the number. Then somebody comes and says, you know what, we have to add a new rule. So you have to add 1 to every number. And somebody else from marketing says, no, but you have to multiply 3 times the number. Okay? So in the end, if you add more rules or the business rule changes, well, it's going to be hard to refactor, right? So it would be easier if we just keep those rules outside. Rule A could be just doubling the number. Maybe rule B could be just adding. Rule B could be add 1. And rule C is just multiplying 3 times. So, okay, how are we going to do this? Well, you can just say, well, then do rule A and then collect rule B, okay, rule B, and then collect rule C. Okay, but this is going to be very inefficient, okay? So, because I want just to do that just in one hit. So, the good thing about closures is that you can compose them. So you can come up with business rule, that is rule A, and then apply rule B, sorry, and in the end, rule C. Rule A, rule B, rule C. And we can say, well, collect as the business tell us to do. And there you go. So if later on we just say that the business doesn't take into account rule B, well, it's less code to refactor and it's organized in a nice way. Okay? So I just wanted to show you this in order to show you how to using composable clusters can help you a lot about how to organize the code. So I think we are going to show you here. What's happening here? Yeah, I'm opening Groovy console. Okay. So there's one more topic that I just mentioned in the 2 concepts that I wanted to talk about. One was accidental complexity, and the other one was modularity. We've been talking about Clojures, but there is still one other thing, which is lazy evaluation, which I think is really important. And it really helps you to refactor and to be efficient when you are collecting your code. And I'm going to show you here, thanks to this wonderful library, thanks to J, which is String Groovy. String Groovy is a library that uses a lot lazy evaluation. And it's very nice to create rules for filtering data and collecting data in a lazy way. Okay, the way we used to do it with collect something or find out something, well, we apply like a filter or a collector, and the whole collector was applied to all of them. And if you wanted to filter some subset of data, you were just looping through all the data, and then you were collecting. And when you just use a string Groovy, you can just apply the filter to every element of the string, okay, which is very convenient. So here we have our generalization, but this time we are using this library. So here I'm using well, this would be another template for doing what? Just for getting a string for a given reader. Then I want just to map all the fields as a CSV field. That means that for every single line, I'm just interested in the tokens, okay? Once every line has been splitted, I'm only interested only on the valid lines. And I have just created a filter, a rule for just inform the string which lines are valid, which ones it has to just send to the garbage. Then once I have the valid lines, I just want to apply a given criteria depending on the value I'm interested in. And finally, I just want to collect that data. Okay? And well, in this particular example, I just want to be there for getting the maximum something. Okay? So here, mixing a little bit things. Here I'm just using Clojure composition for extracting the fields number 2 and number 4, which are the maximum, it's just the visitor score, and the other one is the home score. So I want to take for every line, field number 4 and field number 2, and then get the difference between them. And I'm just doing this nice descriptive line that says just extract the fields as an integer. We'll see the code later on. And then just subtract it. And then in just one line, it's pretty clear that I want to extract the maximum difference between scores. Okay? So there's so little room for error here. Okay? So if we wanted to get the maximum difference on Saturday, it would be easier for us to do that. So, for example, if I'm interested in filter those that have been played, well, in fact, I have already done it because I have just said here, I'm interested in valid lines. So if I just look for valid lines, what I'm going to see is that I have created a Clojure that says that I'm only interested on those lines that are split as tokens that have size 5. So it should have 5 tokens there. Okay? So something that I'm not, something that I don't have to do. Okay? So I have just saved one line of code. I have to. I'm interested in those who have been playing on Saturday, so I have to create like a filter. Is Saturday. Then, well, because I already split the code, I'm just getting here like a line tokens. Okay, so I know that the first token is the date. So what I'm going to do is just to parse it. Parse tokens, dd, and then blah, blah, blah. Sorry, I don't know how to juggle, so I only can code at this moment. Token first, and then, okay, once we have this, we can format. And of course, I have just learned this by heart, because otherwise it's impossible to remember how to format this. So I'm interested only in the 6th day of the week. So I have this filter here, which I'm going to take this and put it right there. And I'm only interested in extracting the fields, okay? The fields, that is the maximum difference. So I would say I'm interested in the same thing that I was here, difference between a score. So I could be just taking this out because it's pretty clear that I'm going to be reusing it. So in fact, I can do that. I just want to put it, let's put it here. Different between scores. Okay. Okay. So in the end, I'll extract the maximum. When it's Saturday. Okay. Let me show you again the refactoring we did here. I'm just going to put it in several lines because otherwise we are not going to be. So here we have our, I would say, our template pattern that we used to see in several processes. So now we can just create a collector and filter data by a given criteria using Clojures. And those Clojures, they don't have to be just one. They can be composed in order to pass the filters to this template. And then, because we are using lazy evaluation thanks to this library, we are going to apply the filters and the collectors for every single line without having to pre-process the data. Okay? So up front, it looks a little bit scary, but in the end, we only have to use, like, just in this particular case, we only have to do just the filter for filtering on Saturdays, okay? And of course, the rest was refactored from even, there are some substructs, okay? The nice thing about here, about functional programming, is that you can abstract more, and not only in a class level, but method level. And maybe some of you can think, well, man, maybe we are getting too low level. Why don't we can just refactor our methods? Of course you can. I think it depends on the way or the use case. I mean, if we were reusing the code among other classes, I would say it would be better just to put that into a method, because you don't know how other programmers can use that. So we can just put it in a method. And we can always just use the, I'm going to say this, we can just use this method as, we can use this convention just to convert or to make a method act as a Clojure and to use it for composition, okay? So I guess it depends on the use case that you are involved. Okay, so it's imperative so bad? Well, I don't think it's bad, but let me reframe the question. Would you keep using Java 1.4? I mean, it was pretty stable at the moment. I was happy when I was using it, but then it came Java 1.5, and it was better. So why don't check it out? I mean, maybe it brings some new features that are really nice, and it did. Okay, so I would say it's the same with functional programming. I try to make this talk really, really straightforward, not to scare people, because functional programming always scares people. People talking about monads, people talking about functors, and those things are really far away from the normal programmer. I mean, I don't want anybody to get scared, because I think functional programming is good for us. It's going to help us a lot, especially tackling accidental complexity. So imperative is not bad. I think it's just a matter that it doesn't encourage you to do the right thing. I think it's a time where there are many other technologies and ideas that are coming out that are really interesting. And of course, things like multi-threaded environments or concurrency or parallel programming, using functional programming really helps you to arrange your code or organize your code in a way that, in case you want to refactor or to plan or design a system, it's going to help you a lot to design it. Okay. Of course, changing your mind with criteria, of course, not for everything. It's good. I mean, I think imperative programming could be something good for us, and I really encourage you just to give it a try. And if you just mix functional programming with Groovy, well, it's even better. I think we will have some fun. Okay. So that's pretty much it. So if anybody has any questions, many questions? No? Oh, okay. Pues, thank you.
How long did it take you to get your head around functional?
Sorry?
How long did it take you to get your head? I mean,
I'm still on it. I'm still on it. I am far from being a functional. Well, I don't want to be pure functional programmer.
Yeah.
But it's just a matter that I have seen that it's something that really helps us to. You can reduce the code, then you reduce the code. You can see the errors, or maybe you can just arrange your code in some other way. But it's just for that. It's not that I'm just doing I'm not an evangelist or something like that. Not at all. I'm very far from it. I'm just in the other side. Is that I've been talking with some friends about this topic, like saying, you know what? When I just go to a functional programming talk or something, it's like, well, you have to do this, and there's no other better way to do this. And just Groovy can give you the opportunity to go anywhere. You can go very functional, you can go imperative, you can go from imperative to functional. But if somebody don't know how to program functional, and you just start saying, you know what, you have to start learning Haskell. It's gonna, in 2 days, it's gonna leave it. It's not gonna go anywhere because it's too complex or too different from the ways we used to program. So I think using Groovy and going step by step is a good way for functional programming. Yeah?
I think I'd like to disagree with you on that one. I think it would be a damn good idea if everybody had a little go at Haskell. Exactly because it isn't Groovy and it isn't Java. And so therefore you're actually looking at the functional abstractions themselves. And then you bring it back to Groovy or Java, and you've brought the abstractions without all the syntactic baggage. You'll make it a lot easier for people to then apply the functional ideas within the Groovy context. So, it's a book like Learn Your Haskell for Great Good or something like that, which is an online book, doesn't cost you any money. Just work through it as a tutorial for a couple of hours every other day or something like that. I reckon within a month you would get it. You know when you're going to have got it.
Yeah, I have to change my mind. I think you are right, because in fact that's something kind of what I'm doing nowadays. Because yes, of course, I'm trying to use functional style in Groovy, but where should I be looking to? well, some functional languages, of course, because if my language is not functional, I can't learn anything functional from that language. So I have to look for a functional language, and that's correct. Okay?
And is Haskell the best one?
I'd like to suggest Clojure.
Disagree.
No, it's just that Haskell is, if you like, the poster child of functional programming, because it represents the language created by the people who developed the functional programming ideas throughout the 70s and during the 80s, through Hope, KRC, Miranda, and into Haskell. But yeah, if you're stuck on a JVM and you can't get Haskell in, Clojure is a good tool, as long as you can remember how to many close parentheses.
Sure. Okay. Okay, thank you very much.